Okay, here we go. It is gonna be March 10th through the 14th. And we're gonna talk about scatter plots again. Functions unit tests. We'll go through a few of those if we can. Systems of equations, word problems. So both of these are review, but I do think that we're getting more into the actual system and less into the people just Googling answers, which was happening before. Okay, so here we go. Let me go over to the board and let us talk about, okay, the graph below. Where is the graph? What do I get? It's chords here. Okay, I am stuck. There we go. All right, got it. The graph below shows the relationship between the life expectancy and the infant mortality rate in a random sample of countries. Which statement is the best description of the association between these variables? Okay. Countries with the higher infant mortality rates tend to have longer life expectancies, tended to have shorter life expectancies. There's no clear relationship. All right, so how do we do this? Let's begin the same way I told you to in the last video. So we're looking at the axes here. And so let me get out of the annotation here. Okay, so life expectancy is the y-axis and infant mortality is on the x-axis. So here we see we have a dot at about 0.53, which means that life expectancy is about 53 when infant mortality is 0. But then as infant mortality, life expectancy is about 18 when infant mortality is at a rate of 91. Okay, so from last week, we talked about positive, negative, linear, nonlinear. You should be able to see that this is a negative association. Okay, which means as the x value increases, the y value decreases. So as the infant mortality rate, the x value gets higher, the life expectancy gets lower. That's a negative association. So let's find out which one says that. Higher infant mortality, and we know that is the, so now when I'm reading these choices, I'm looking to see where's my x and where's my y, because I know that as x increases, y decreases. So higher infant mortality, that means they're talking about x increasing, tend to have longer life expectancies. That's my y value. Longer also is an increase word. That's not right because that's saying as x increases, y increases. Now, okay, let me get rid of some of this stuff. How about this one? High infant mortality, so that's talking about x increasing, have a shorter life expectancy, y decreasing. And I know that is what I had said. And we know there is it's not C because we do see a pattern. That's how you do that. And I'm not gonna talk about this one as much. We're just gonna, so here we see a positive association. So that it gets a little bit less, the strength kind of decreases as it goes on. Oh, I love this example, study time versus test score, right? So we do see a positive association, which means as x increases, y also increases. As study time increases, test scores increase. Students who studied more tend to score higher. Okay, so that is the describing trends in scatter plots. And so give that one a try, postal traffic light problem, and let's look at the next one. So not only do we look at trends in the data, but we also use scatter plots to make predictions about the future. And we do that by graphing that line we keep drawing and using the line to make the predictions. So which line fits the data graph below? So when you're trying to choose the line that best fits the data, it should be the line. I'm going to type this one. I want you to write it. The line that best fits the data is the one that is closest to the most points relatively. So it's like not the one that goes through the most points or anything like that, but it's the line that describes the pattern the best. And so you can clearly see that's A, right? B is far away, C is far away. This is A all the way. Let's see if we can get a more difficult one. Okay, so this one is interesting because the data is like this. So part of the line is described by the orange line, part by the red, and nothing really by the green. But there's no one line that fits it, right? So I'm going to say no. So you can try that one. And the cool thing about these assignments is they should be kind of easy so that we can, focus in on those unit tests. Okay, Shira's math test included a survey question about how many hours students spent studying for the test. And just so you know, you do have to write down this word problem. We're not doing a lot of word problems, but the ones in the video should be in your notes. Should write down every word here. The scatter plot below shows the relationship between how many hours students spent studying and their score on the test. Which of the following is the best estimate of the average score change associated to 1 hour increase in study time? So after you write this down, just circle it and write, they are asking for the slope. They are asking you for the slope or rate of change or unit rate. All these words. In one of the classes, we said rate of change, and nobody knew we were talking about the slope. So make sure you know all three of those words are the same thing. Okay. So let's look at the scatter plot and see if we can find the slope here. So it's asking us which is the best estimate of the average score change associated with 1 hour increase in study time. This is a tough one. So we're going to have to kind of draw a line and estimate the slope. So we are estimating the slope. Wow. Okay. So I am going to draw a line of best fit that I think is pretty good. And now I'm going to pick 2 points on that line, draw a slope triangle. And I got 1, 2, 3 boxes. But if you look at the axis, it's not 3 because they're counting by 0.5s. So even though it's 3, it's actually 1.5. And on the y-axis, they're counting by 10s. So how many boxes? 1, 2, 3 also, but that's by 10, so that's 30. Okay, so be real careful on this one. That's all I can tell you. So the slope is 30 over 1.5. about, right? So that would be, I would say about 20. So let's see if 20 works. Again, I just drew a line. Let's see, I got it wrong. And it says tutor me. So now this is good because I'm gonna see if they can tell me what I did wrong and if I understand it. So look, they drew a line, I drew a line, we both drew a line. The line approximately goes through these two points. So the approximation for the slope is 10. 1 hour increase. So the only thing that I should do differently next time is draw a better line. So if you draw a line and it's not that good, then just draw a better line. And how do you know if it's a better line? Well, it's going to go through, it's not going to go through the most points. It's going to be the line that is the closest to all the points relatively. So if one point is this far away on one side, then the other point is this far away on the other side. It's like equidistant. And it describes the pattern. So my mistake was that my line started too low and went too high because my slope was too steep. Okay, so now you get to try that one. Good luck. All right, but you can do traffic light problems. At least the steps we took was, same steps. All right. Now, we are going to do this word problem here, but a lot of people got 100% on systems of equations word problems. And I said to myself, really? Because I really thought we should have went over that in class. Because I know that if I put it on the test, it's not going to be 100%, even though you came to class with it. So let's do this together and don't Google the answers or do any funny ways of getting answers that you can't reproduce in class. If you don't know how to do it, don't get it right until you know how to do it. I mean, that's what we need to do in order to learn. So let's read this. Yachanan walked home from school to the bus stop at an average speed of 5 kilometers per hour. He immediately got on his bus and traveled at an average speed of 60 kilometers per hour until he got to school. The total distance from his home to school is 35 kilometers. The entire trip took 1.5 hours. How many kilometers did Yachanan cover by walking, and how many kilometers did he cover by traveling on the bus? First thing I do is I look at that question, and that tells me the variable. Tells the variables. The variables are always going to be what we're looking for. So we are looking for how many kilometers he covered by walking. So we can call X equals km by walking. And Y equals km, what is it, by driving, by bus. So those are the variables. We know a system of equations is two equations. So what do our equations represent? Well, we also see the total distance from his home to school is 35 kilometers. When I see that word total, I think sum, right? So we know that our variables represent distance, and the total distance is right there. So that means X plus Y equals 35. And then we know the entire trip took 1.5 hours. And so we know the rate at which he traveled, right? And I know that distance equals rate times time. Distance equals rate times time. So I know my total time is 1.5 hours. Okay, and so this first equation is about distance. And the second equation is about time. And so I want to write my two expressions for the total time. Okay, so if we know they traveled 60 kilometers per hour, then what are we going to write? If we write 60 times y, then that means we're multiplying 60 by the miles. That's not going to give us the total time. The total time would be given by taking the distance and dividing it by the rate. I know that because d equals RT. That means T equals d divided by R, right? If you take this equation, this formula from Mr. Wolf's class or Ms. Crespo's class, and divide both sides by R, then you get T equals D over R. So I don't want to do 60 times Y. That's not going to give me the total time. I want to do the distance, which I don't know, but I know the rate is 60. And then the distance for walking, which I don't know, but I know the rate was 5. Okay. So you see, I really don't think that anybody knew how to set that up and solve it easy breezy, lemon squeezy, and then come to class and take a test on it. But so many people got this one right on the computer. Whew. I wouldn't have got this one right if I was in 8th grade. So now, what are we going to do? We are going to get rid of those fractions, and the way we're going to do that is by multiplying, like we did in class today, by the denominator. We're going to multiply by the LCD, and that will get rid of fractions, which I think we would all appreciate. So let's multiply by 60, and then we get 60x over 5 plus 60y over 60 equals 60 times 1.5 is 90. And now I'm going to clear all this and rewrite it so that I have more space. So now I just forgot what it was. Okay. So 60x over 5 plus 60 over 60y. Okay. 60x over 5 plus 60 over 60y equals 1.5. And then, of course, x plus y equals, was it equal? It equals the total distance, which I forgot, 35. Okay. Okay. So we're multiplying everything. We multiplied everything by 60. And now we can reduce. So 60 divided by 5 is 12. And 60 divided by 60 is y. And then this was actually 90, so that's 90. Okay, and then x plus y equals 35. So now, after all that setup, we can solve this system. And then we're not going to do another one right now, but we can do as many word problems as you want when you post them as traffic light problems instead of getting them all right. So I am going to label my equations 1 and 2 and review for you right now, solving by substitution. Don't worry, it won't take that long. We're not going to write the success criteria again because you already have it. So you take equation 2 and put it in slope-intercept form. So y equals negative x plus 35. Remember that? Then we take the mx plus b part and we're going to substitute it into equation 1. So for y, right? So 12x plus negative x plus 35 equals whatever that is, 90. Right? Okay. Now 12x minus x is 11x plus 35 equals 90. Now I subtract 35, and we get 55 equals 11x, which means x equals 5. And then I know x plus y is 35, right? So if x is 5, that means 5 plus y equals 35, which means y equals 30. So he drove 30 miles and he walked 5 miles. That's crazy. That reminds me of when I was your age and I had to walk 5 kilometers instead of miles. 5 kilometers. Thank goodness that was right. I did not want to go back through that. Okay. So ask any questions about that you want in class. We'll even do the success criteria in class because we're going to take just a few minutes and go through the functions unit test. What is the slope of the line that represents this relationship? Graph the line. Well, that's not a problem for us, right? We know that. Okay, we know the slope formula. Y2 minus Y1 over X2 minus X1. And so we got X's, so this can be X1, that can be X2, Y1, Y2. 3 minus 0 over 1 minus 0 is 3 over 1 is 3. And it goes through 0, 0. So this is back to like January, first week of January. We should. Now what I says, I'm almost there. Okay, let's put the 3 there. Oh my goodness gracious, it says that I am not quite, but I see why. It's because you see the line, I was at 3.5, checking in. You see, sometimes you got to get them wrong on purpose so that you guys feel encouraged that these are difficult. I don't want to just make it look easy and then anyway. Okay, so if the input is 6, I wonder how many people remember this one. So write this little graph down, put inputs next to the X and outputs next to the Y. And if the input is 6, we go up and then graph and we get an output of 8. So when the input is 6, the output is 8. So James is playing his favorite game at the arcade. After playing the game 3 times, he has 8 tokens remaining. He initially had 20 tokens, and the game costs the same number of tokens each time. The number T tokens James has is a function of G. Okay, so when I read this, I see a few different things. I see that he has 20 tokens initially, which is the y-intercept, that means we have the point 0, 20. I also see that he has 8 tokens remaining after playing the game 3 times. So T is the number of tokens. That's going to be T as a function of the number of games. If you see that, so that means 3 games, we have 8. Okay, so now we got to write the functions formula. That means we got to write the thing in slope intercept form. So we'll label our points x1, y1, x2, y2. We'll find the slope. We already got the y-intercept, and that's it. So 20 minus 8 over 3 minus 0 is 12 over 3, which is 4. So this function is 4x plus 20. We found, identified our 2 points. And how do we do that? How did I do that? I looked at the words after the numbers, tokens, games, and then it says T is tokens, G is games. That's kind of how I do that. Okay, we figure out what our units are. Follow the right. Okay. Please, your answer includes the wrong variable letter. There we go. Take it right. Okay, not quite yet. Show steps. Okay. -4. Ah, okay. So it's -4G plus 20. All right. I knew that the tokens are decreasing. But why did I? So if you look x2 minus x1, and then up top, I put my y1 minus y2. And I wonder if you caught that and you said he's going to get it wrong. All right. But hey, okay, we heard the noise there. Okay, we already did this one. And so go through this in an effort to capture your traffic light problems. Okay, because we're doing the functions unit test. And then down here, we're going to come back to the functions unit test. We're going to do functions quiz 4. Okay, so this isn't going to be the last time we look at it, but this is an important thing for you to do. All right, and you don't need to get 100% on it, but you do need to capture all your traffic light problems. It's a long test. Okay, and so if we get some of them, then that'll be good. And you should see that it's a little bit easier based on the stuff we're doing now with lines and scatter plots and all of that. All right, I will see you in class. Bye for now.